Hello, we are Acceletrix, a team based in Newcastle upon Tyne at the Royal Grammar School, proudly supported by our sponsors Lovell Homes and Garment Printing. Our team members are Ethan, Adam, Anish and Thomas. Led by Mr. Lowe, we have managed to create a functioning Scalextric car that we will show you today. Here is a word from our sponsors.
Hi, I'm Phil Jones, Head of Land and Partnerships at Lovell Homes. We are a house builder and a contractor, and as such it's all about creating places. This involves technical due diligence, problem solving and being creative and innovative thinking. It is these transferable skills that are clearly evident in the RGS submission for the Scalextric competition, and that's why we're absolutely delighted to be a main investor in the competition for them.
We started off our design and development process by writing down what we wanted the car to be and the specific engineering factors involved. This included things like having the motor lower down to ensure a lower centre of gravity, as well as implementing a bearing system to allow smooth and efficient rotation of our wheels. Because the motor has a strong rotational force, we have secured it tightly using two 3D printed parts which are connected to two larger pieces that house both the front and rear wheels. Before we attach the wall pieces to the base, we have to add the bearings. We have tested a variety of bearings and we have chosen to use deep groove sealed steel ball bearings for their durability and efficiency. These specific ball bearings have an inside diameter of 2.4mm and each contain 10 steel balls. They allow for the front and rear wheels to be positioned precisely above the ground and keeps the axles from rotating. I would also like to draw attention to our clip mechanism, which is just a simple triangle extrusion that runs from the front wheels to the back. This allows the body to be clipped onto the car, enabling a modular system, meaning in future the chassis can be used with different car designs. Another feature of our car is its headlights and taillights. We have manufactured our own PCBs and connected LEDs from the motor to the PCB to the front and back of the car. Our final design has come quite a long way from our initial ones. Here you can see that previously the body was placed on top of the chassis, meaning it had to be cut. The clips on the side also did not run the entire length of the car and were prone to breaking. Now we will move on to the manufacturing processes. Most of the components of the car are 3D printed, like the chassis. After printing, they are sanded down to ensure that they fit together. On some pieces like the body, we need to remove the support filament that allows the piece to print smoothly. Once all the parts are prepared, we can simply assemble the car together. No super glue is required during assembly. The bearings are also added to the axles in this step, since they will be held securely by the walls of the chassis and cannot be accessed after. For our headlights and taillights, we designed custom PCBs in order to connect the power to the LEDs. We printed out our design onto acetate and let it expose in the UV light box, removing the top layer of photoresist. After exposing, the PCB is developed by rinsing it with a solution of hydrogen peroxide and water. This helps fully remove the photoresist only where the copper tracks aren't. After that, we put the developed PCB into the etch tank where it dissolves all the copper except for the areas that still have the photoresist layer. Now we have to prepare the PCB for soldering. We sand it down, drill holes, and scrub the surface with steel wool to make things easier. The result is a shiny, ready to solder custom PCB for the headlights and taillights. For testing, we worked with Team Velocity on the track in school. We made sure that the track was built properly and it also allowed us to practice our driving skills for the competition.